What if an inventor could develop something so extraordinary that it had the potential to influence the way entire industries do business in this country? What if this inventor could design a superstructural material that was so strong it would revolutionize the way engineers design and manufacture structural materials used in everything, from fire engine ladders to steel girders and skyscrapers? What if this technological innovation was so radical that it would do for the steel beam what the steel beam did for the wood beam of centuries past? Just such a breakthrough has occurred. A.J. Sesternino received a patent in December 2012 that will not only impact the world of structural engineering, but will also have a positive influence on our environment. His patent is changing the way carbon fiber, the strongest substance known to man, can be used to improve our world. His technology will require fewer natural resources, like trees, to be consumed in the construction of many products currently being used today, like railroad ties and telephone poles. Worldwide, these two products alone consume a multitude of trees each year. Mr. Sesternino's solution helps address this natural resource problem, as well as helps reduce the amount of discarded plastics impacting our landfills. With respect to railroad ties, Mr. Sesternino's technology avoids the limitations currently associated with concrete and synthetic railroad ties. His proposed railroad tie is not subject to fracturing from vibrations causing premature failure, which is associated with the concrete tie. And with respect to the synthetic tie, Mr. Sesternino's railroad tie is capable of handling much heavier loads due to the presence of a carbon fiber rod insert. Mr. Sesternino has designed a synthetic utility pole using discarded plastics from landfills that includes his carbon fiber rod insert. His synthetic carbon fiber poles are stronger, lighter, are environmentally friendly, and much longer lasting than wood poles. Several Canadian municipalities have expressed an interest in Mr. Sesternino's project and would be receptive to purchasing his synthetic carbon fiber utility pole once they go into production. Mr. Sesternino's utility pole design can be slightly modified to be used in the construction of outdoor entertainment structures that will not be subject to wind loads that can cause structural failures and collapse. Highway safety is a concern for us all. Mr. Sesternino's carbon fiber insert in highway safety rails will add to their safety, making them less susceptible to impact failure. Mines, tunnels, and bridges can all benefit from this technology, especially the girding up of our aging highway bridges. The testing that was done at Washington State University to prove the practicality of Mr. Sesternino's patent confirmed that 1. The encasement of the carbon fiber rods in a protective jacket was a viable approach to solving the attachment problem, where carbon fiber rods would not have to be drilled or laminated, which weakens them structurally, thus limiting their usefulness. Secondly, a carbon fiber rod could be made larger than 1 5/8 inches, a serious limitation plaguing the carbon industry industry. By overcoming the limitations of size, carbon fiber rods can conceivably be fabricated to any size needed to meet major construction needs, like making large bridge and tunnel beams, which would be able to carry much heavier loads than what is currently possible today. What does Mr. Sesternino need from you? He needs your support through your donations to enable him to do what the carbon fiber industry hasn't done. Build a machine capable of moving the use of carbon fiber to a whole new level of serviceability and at the same time reducing the impact on our environment. This is an environmentally friendly solution to our human resource needs. Mr. Sesternino's machine is essentially a modified protrusion machine that not only shapes the carbon fiber, but cures it in one operation. Carbon fiber strings start at one end of his modified protrusion machine, and a completed carbon fiber rod emerges at the other end, built to the size and shape specified. Mr. Sestanino built his own autoclave to cure the carbon fiber rods he made for his patent, at a fraction of the cost of autoclaves being sold by manufacturers. Carbon fiber industry spokesmen were surprised that Mr. Sestanino could build an autoclave out of mining pipes, oil drums, and electric stove parts, and cure a carbon fiber rod larger than 1 5/8 inches. After having designed and built gold mining machines for use in African riverbeds, Mr. Sestanino sees this project as a no-brainer. Thinking outside of the box not only has had its rewards, but has also brought its own set of problems. Just as with the encasement solution Mr. Sestanino presented to the carbon fiber industry, he is now encountering the same lack of vision with his modified protrusion machine. Your help will enable Mr. Sestanino to bypass an industry's reluctance to change and open the door for environmentally friendly solutions to a multitude of structural challenges.